All right, let's get right into it. We're going to pull back the curtain on one of the absolute biggest breakthroughs in modern AI. This is the technology that lets models like GPT and BERT actually get what we're saying. This, right here, is the secret sauce.
So, to really see the challenge, just look at this phrase. The judge issued a sentence. Simple enough, right? But the word sentence could mean two totally different things, a line of text or a prison term. For us, it's obvious, but for an AI, it can't just look at the word by itself. It has to see judge and instantly connect it to sentence. But how in the world does it learn to do that?
Well, the answer was a totally revolutionary aha moment in AI research. And it's an idea that was actually inspired by the way our own brains work. It's called the attention mechanism.
At its heart, the attention mechanism is, well, exactly what it sounds like. When you read that sentence about the judge, your brain didn't treat every word equally, did it? Nope. It instantly zeroed in on judge to figure out the meaning of sentence. This mechanism gives AI that exact same superpower, the ability to focus, to weigh the importance of different words, and to grasp the real context.
And you have to understand, this was a total game changer. Before this, older models processed text one word at a time. This created a massive bottleneck. It was like trying to remember the first word of a story by the time you reach the last page, nearly impossible. But AI with attention, it sees the whole thing at once. It can connect a word at the beginning of a document to a word at the very end, creating a way richer understanding.
So how does this actually work? Is it some kind of magic? Well, not exactly, but it is really clever. To get how an AI pays attention, we need to pop the hood and look at a system that works, believe it or not, a lot like a search engine.
The easiest way to wrap your head around this is to think about something you probably do every day, searching on YouTube. The words you type in, that's your query. YouTube then matches your query against the key of every video. Think of the key as its title or tags. When it finds a great match, it gives you the value, which is the video itself. Okay, now hold that thought. Query, key, value. The attention mechanism does the exact same thing, but with words inside a sentence.
All right, so let's walk through it. First step, the query. Every single word basically shouts out a question. Hey, which other words in here are super important for understanding little old me? At the same time, every other word holds up its key, kind of like a sign that says, this is what I'm all about. The model zips through, compares the query to every key, and creates a score based on how well they match. Those scores get turned into attention weights. Finally, each word's real meaning, its value, gets multiplied by those weights. And boom, you get a brand new understanding of that word, now packed with all that juicy context.
So, to tie this all up, deep down, every word is just a bunch of numbers to the AI, right? That's called a vector. The model takes that one vector and cleverly creates three new ones from it. The query, what the word is looking for, the key, what the word has to offer, and the value, the actual substance, the meaning, that gets passed on once all the scores are settled.
Okay, so that's the theory. But here's where it gets really wild. What happens when you let a massive model like Google's BERT loose on billions and billions of sentences? What kind of relationships does this attention thing learn to see all on its own?
It's fascinating. The model actually has lots of these attention mechanisms called attention heads all working at once. And what happens is each one starts to specialize. Without anyone programming it, they just learn grammar. One head will get really good at connecting verbs to the thing they're acting on. Another will figure out how pronouns like she connect back to the woman. They're literally rediscovering the rules of language from scratch. And that right there is the magic. Seriously, this isn't some engineer painstakingly coding in the rules of English. These complex abilities just emerge. They pop up naturally because the AI figures out that the best way to do its main job, predicting missing words, is to first understand grammar. How cool is that?
But you know, this incredible power, it creates a huge new problem. The very thing that makes attention so powerful, the fact that it can compare every single word to every other word, well, that becomes a massive computational headache, especially when we start feeding it longer and longer texts.
So here's the catch. As the AI is generating text, it needs to remember all those key and value vectors from the words that came before. To be efficient, it stores them in something called a KV cache. You can just think of it as the AI's short-term memory. But with every new word, this memory gets bigger and bigger and bigger, eating up a ton of precious GPU memory.
For a short little tweet, no sweat.
But what if you ask it to summarize a whole book, or have a conversation that lasts for an hour? That memory cache just explodes.
It gets so big that it can overwhelm even the most powerful hardware out there, creating a serious bottleneck.
The first fixes for this were, well, clumsy. They tried moving that memory cache to a slower part of the computer. But imagine if, every time you wanted to remember something from 2 minutes ago, you had to get up and walk to another room to look it up. That's kind of what the AI was doing. It was painfully slow and created this huge lag.
So that's the million-dollar question, right? How do you get massive memory and lightning speed? Well, this is where we get to the really cutting-edge stuff. Researchers realized that constantly fetching data for every single word was just wasteful. And that led them to a much smarter approach called LuiKV.
The big breakthrough came from simply watching how the AI behaves. First, they saw its focus doesn't just jump around randomly. It sticks to one topic for a while before moving on. And second, they noticed it pays attention differently depending on the task. When it's reading a long document, its attention is sparse, like finding a few needles in a haystack. But when it's writing, its attention is dense, focusing really heavily on what it just wrote.
So using these insights, LuiKV does something way smarter. Instead of the old brute force method of grabbing data for every single word, it has this nifty little detector that can tell when the topic has changed. And only then, at these semantic boundaries, does it bother to go and retrieve new information. This massively cuts down on the slow, tedious work.
But wait, it gets even smarter. It actually manages its memory in 2 different ways. For that needle in a haystack problem with long documents, it pre-groups similar ideas into semantic clusters. But for the text it's writing right now, it just keeps recent thoughts bundled together in temporal segments. This fine-grained approach means it can grab the exact information it needs exactly when it needs it. No more wasted effort.
So what's the bottom line here? A huge performance boost. We're talking up to a 4.7 times speed up over the previous best methods. And this is the crucial part. It does this without losing any meaningful accuracy. This isn't just a small tweak. It's a fundamental change that makes working with enormous amounts of text way more practical.
Which brings us to one final, really exciting question for all of us. The attention mechanism gave AI the power to understand context. Now, innovations like LuiKV are making that power incredibly fast and efficient, even at a massive scale. So as we keep smashing through these memory and speed barriers, you have to wonder what previously unsolvable problems are next. What challenges in science, in research, in creativity will AI finally be able to tackle? The possibilities really are just starting to open.